Hello students, this is Faizan Mirza. We are discussing the hormonal control of menstrual cycle. In this part of the video, we'll be discussing the hormones, the four major hormones, namely estrogen, progesterone, FSH and LH. These four hormones and how are these involved in regulating the menstrual events and the main hallmarks of the menstrual cycle, the organs involved and the changes involved in it. So let's start our discussion of menstrual cycle. When we're discussing the hormonal control of menstrual cycle, we actually restrict ourselves to the hormonal control, as in the details of what the hormonal interplay is involved in regulating the menstrual cycle. So to understand the details of hormonal control of menstrual cycle, we have to look into the details of the menstrual cycle itself. Although our emphasis will still be on the hormonal control. Menstrual cycle, there are two distinct cycles occurring simultaneously. First, or you can say one is the ovarian cycle, the other is the uterine cycle. They both occur simultaneously, and multiple body parts, if you number them, so there are four main body parts which are involved in menstrual cycle, namely the anterior pituitary gland, which releases the hormones, the circulatory system, which distribute these hormones around the body, number 3 the pair of ovaries, and number 4 uterus. This diagram shows to you the details of an ovary in a human female. So this is an ovary. Inside an ovary there are several follicles present since the embryonic life of this female. A potential female gamete starts to develop. So inside this follicle, a potential female gamete will be developing. The potential female gamete is dividing and it's just growing inside here. At the same time, the follicle in which it is residing, the follicle is growing as well. This becomes the primary follicle. So multiple follicles were growing. Out of these, one of them will grow more than the others. It becomes the primary follicle. The primary follicle is produced by development of tissues surrounding the developing gamete. So the developing gamete will still be here, the potential gamete, and the tissue surrounding it is the primary follicle. The primary follicle then grows on to become the secondary follicle. The secondary follicle then grows and matures to become a Graafian follicle, and inside the Graafian follicle, this is the gamete, still not fully matured though, and this is the fluid filled space. So this is the nutrients, or you can say the nutrient nourishment providing tissue for this gamete, and this Graafian follicle holds this gamete. Now the Graafian follicle ruptures. When the Graafian follicle ruptures, it releases the egg or this gamete into the oviduct out of the ovary. The remaining Graafian follicle turns into corpus luteum. This process is called as ovulation, where a Graafian follicle ruptured to release the egg and turned into corpus luteum. Corpus luteum persists for a few days, and after that the corpus luteum disintegrates into corpus albicans and it stays within the ovary. Now let's go to the details of the hormonal interplay. So this is the human brain, and in the human brain this is the hypothalamus, and below the hypothalamus you have the anterior pituitary gland residing here, and this is the hypothalamus, so they work in close collaboration. So the anterior pituitary gland is present here. The anterior pituitary gland is the one which responds to the hormones coming from the hypothalamus. So we'll be going step by step to understand what's happening here. So the hypothalamus releases some releasing hormones which we won't discuss in detail at this level, and those releasing hormones stimulate this anterior pituitary gland to release FSH. So the first thing is that FSH is secreted into the blood. FSH travels to ovary and once in the ovary, it causes the growth of follicles in the ovary, and estrogen is released. The estrogen which is released, it goes to the uterus and it initiates endometrium growth. This lining inside the uterus is called the endometrium. Estrogen also travels back to the anterior pituitary gland and inhibits FSH via a negative feedback loop. Further ahead, hypothalamus stimulates the anterior pituitary gland to release luteinizing hormone LH, which causes ovulation. It travels in blood. It acts on the Graafian follicle, and the Graafian follicle in the ovary ruptures to release the egg. This egg is released into the oviduct, and the Graafian follicle becomes the corpus luteum. The corpus luteum is produced as the Graafian follicle ruptures, and the corpus luteum produces a hormone called progesterone. Progesterone goes to the uterus and helps in building the endometrial lining even further. Another thing that the progesterone is doing is it will go and it will inhibit LH. So more luteinizing hormone is not secreted. Eventually, this corpus luteum will live for a few days. After that, the corpus luteum will disintegrate and the progesterone level will drop, and the endometrial lining, which was maintained by the hormone progesterone primarily and estrogen slightly, will be shed. The hormonal profile can be plotted on a graph. This line here shows to you ovulation. This period shows to you the menstrual discharge, which occurs during day 1 to day 5. On y-axis, I am showing to you the level of hormones, and on x-axis are the days of the cycle. This line represents the hormone progesterone. So you can see that progesterone is low from the very beginning of the cycle, and around ovulation it starts to rise, and after ovulation it goes to a peak, and after that it slightly declines and eventually comes to its baseline level, which marks the end of one menstrual cycle, 28-day menstrual cycle. This is the graph of estrogen. You can see that the estrogen rises gradually during the first half of the cycle. It was initially low, it rises gradually, it fluctuates slightly, it drops down around ovulation, and after ovulation it starts to increase as well, but it doesn't reach the same peak as it went initially in the first half of the cycle, and its level stays low as compared to progesterone in the second half of the cycle post ovulation. And estrogen also declines eventually by the end of the 28-day cycle. This graph shows to you the other two major hormones, FSH and LH, on the very same days. Day 1 to day 5 again is the day these days during which the menstrual discharge will be occurring. You can see that this FSH and the LH, they both follow a similar trend. They are both low initially, they both increase gradually. LH stays lower as compared to FSH. FSH increases slightly and then it dips down. And FSH raises again during ovulation. And again it dips in the second half of the cycle and stays low till the end. Again it starts to rise when the cycle, a new cycle is about to begin. If you compare this to LH, LH also follows the very same trend of FSH. It stays lower than FSH, but around day 12 to day 16, and mainly on day 14, where ovulation occurs, the LH rises sharply. So there is a high surge of LH during this day or during these days, and this LH coming from the anterior pituitary will cause the Graafian follicle to rupture and release the potential gamete into the oviduct. The LH after that will fall down. If you look at these two graphs, you can compare that somehow the peaks are inverse. When you are having a peak of estrogen, you are not having the FSH and LH peaks. And when the peak of progesterone is there, again the LH and FSH are low. And at the time when FSH and LH were having a high peak, progesterone and estrogen were low. So estrogen is an inhibitory hormone for FSH, and progesterone is the inhibitory hormone of LH via negative feedback. We'll be discussing these events occurring in the ovarian cycle and the uterine cycle day-wise. Day 1 to day 5, what's happening in the menstrual cycle? Initially, you can see that this is the condition of the uterus, this is the ovary, and this is the potential gamete developing there, and the lining is being shed. This is the endometrial lining which is being shed. This menstrual discharge is occurring. So this is the day 1 of the cycle, which is marked by the shedding of the lining. Why the lining sheds? Because the hormone progesterone is low. So the low level of progesterone mainly and the low level of estrogen, it stimulates the endometrial lining to get shed. At the same time, what's happening in the ovary? Ovaries respond to a high level of FSH and slightly high level of LH as well, but primarily FSH, and potential gamete in the follicle starts to develop. And the follicles, they begin to grow. The growing follicles in the ovary, these follicles, they produce and release estrogen. In the ovaries, they will go from the ovaries into the bloodstream, and eventually they will enter into the uterus, and they will cause the lining of the uterus to become repaired. So estrogen is produced and released from the growing follicles of the ovary. The hormonal estrogen will then enter the blood, and it will travel in blood to the other organ, which is uterus, which will respond to this estrogen. What happens during day 6 to day 11 of menstrual cycle? Estrogen level stays high as further more follicles grow, and one follicle will outgrow the others in the ovary, and this follicle will become the primary follicle. This is the event in the ovary. Now when this follicle becomes a larger follicle as compared to others, and this is releasing estrogen, this estrogen, as I told you, would travel to the uterus through the blood, and it will initiate the repair of endometrial lining. The endometrial lining begins to repair. The primary follicle then turns into secondary follicles, and finally it turns into a Graafian follicle, and the Graafian follicle still keeps releasing estrogen. This high level of estrogen keeps causing the endometrium growth further ahead, and the endometrium lining becomes more thick. You can see this in the diagram as well, that by the time the gamete is developing, the primary follicles are growing, and this is a Graafian follicle here with the fluid-filled cavity. This lining is now much repaired as compared to the previous diagram. Then comes day 12 to day 14 of the menstrual cycle. The events in the ovary around day 12 to day 14 are because of the hormone LH, which comes at a high surge, and slightly because of FSH, but primarily because of LH. The Graafian follicle ruptures, the egg is released into the oviduct. This is called as ovulation, and the Graafian follicle, the remnant of the Graafian follicle, turns into the corpus luteum. Corpus luteum is a tissue. It releases progesterone in high quantity and estrogen in some quantity as well. These hormones will enter the bloodstream, and they will travel to the uterus, and in the same days, the endometrial lining will thicken further as it responds to not only estrogen but progesterone as well. The higher the progesterone, the more thickened the lining will be. So you can see here the lining is way more thickened as compared to the previous diagram, and this thickening is primarily because of progesterone being so high. You can see that the Graafian follicle has ruptured, and this will soon become corpus luteum. So this diagram shows the corpus luteum being formed, and this is why, because of high level of progesterone, the lining is thickened. Till day 28 of the menstrual cycle, things will stay almost the way they are. The only difference will be that the gamete will keep on traveling to the oviduct and come into the uterus. What will happen in the ovaries at the same time? Till 28th day, the corpus luteum persists. And as it persists, it keeps releasing high levels of progesterone and some level of estrogen together with it. How the uterine lining will respond to it? The events in the uterus will be that the endometrium keeps getting more spongy, and it stays spongy, it stays maintained, it stays in a thickened state. You can see that the lining is very well thickened here, way more thickened as compared to the previous diagrams. What happens on the day 28 then? The 28th day of menstrual cycle marks the events in the ovary where the corpus luteum will disintegrate and turn into corpus albicans. Corpus albicans is a degenerative tissue. This causes a drop in progesterone level and estrogen level. A sharp decline occurs in progesterone and estrogen, and because of that, the uterus cannot respond to the progesterone anymore since the progesterone level have dropped. As a result, the lining, which was thickened and maintained because of high level of progesterone and estrogen, gets shed. As the lining gets shed, new cycle begins, and this marks the day 1 of the new cycle. You can see that the lining that was shed, the line that was made initially, it is being shed now, and again another gamete is ready to respond to FSH so that it can respond to FSH and become primary follicles, and then secondary follicle, and then graphene follicle as well. That's it from my side. Thank you so much.